I'm really excited to be here today and to share some information that we've never shared with anyone before. But before we get started, quick show of hands. How many of you are responsible for infrastructure for analytics? How many of you care about performance? What about cost per query? Wow, okay. Last question. How many of you run both a data warehouse and a data lake? A lot of you. All right, I lied. One more question. How many of you wish you could only run one instead of both? Only some of you. Less interest there. All right, so this gets to the premise of the talk today. This is the first time we're talking in public about some of the work that we're doing at NeuroBlade. So it's exciting for me to share some of what we're doing. We've done 3 integrations with 3 different query engines on the data lake side. And for the first time, I'm going to talk about one of them in public. The other 2 I can't talk about so much. We've worked with Velox, which is an open source project with Meta, and we'll talk about that during the course of this conversation. Before we get into details, a little bit about NeuroBlade. We were founded in 2018. We have about 120 folks working on the hardware product that we're going to talk about today. We've raised over $100 million of capital, and we're based in Tel Aviv, Israel, as well as in Palo Alto, California. Most of you know what's on the right-hand side. For the few of you that didn't raise your hands, most modern analytics involve some combination of data warehouse and data lake. The premise of data lake was you don't need a warehouse because your performance is fast enough on big data. Unfortunately, we haven't quite gotten there yet. The data lake technologies we see today evolve performance and get us closer and closer and thin the line. But the problem we have with warehouses is we're in perpetual offload mode. We're always pulling data out of the warehouse into the lake. The warehouse never empties, and the lake is never fast enough. You also have semi-structured, unstructured data in the lake. You're already doing ETL or ELT, depending on the mode that you have, both into your warehouse and into your lake. The problem's worse. It's distributed between on-prem and the cloud. So now you've got 2 places to manage the data as it moves. We're also seeing an evolution. Yesterday, the day before, we ran gigabytes of data and scanned gigabytes of data in a query that we ran. Today, the norm is I want to scan a terabyte or a handful of terabytes. Where we're headed to is I want to scan a petabyte or multi-petabytes of data to answer a single question. What's worse for us on the infrastructure side, we're just getting started. The questions are rudimentary. And for better or for worse, the more complicated and more specific a question I can answer, the bigger difference I can make on the business. Which means the trend is going to continue to go up. But we have a bottleneck in the system, the one we rarely talk about. You can only get and process so much data through a CPU. And that data rate is increasing, but increasing slowly. So we're looking for alternatives. There are a couple on the market, but they don't really move the needle too much. On the other hand, when we look at performance on the disks, the things that actually hold the data that we have, I/O throughput is jumping leaps and bounds. It doubles every few years, and we have effectively wasted throughput. We have throughput, we have the data, we can't feed it to the CPU fast enough. And finally, are your users saying, can I speak to your systems in English yet? No. That's where we're going with ML and AI. If it's just your existing users, they're going to iterate a little bit more. But the promise of large language models is anyone can ask a question. It'll automatically be converted to SQL, and you'll automatically get an answer. Not only does that open up questions to more people in the company, but it opens up more questions. Because we as humans like to refine the questions that we ask. We ask simple things, then we refine and iterate over and over and over again. And the answer is to not feed the data through the CPU, to manage all of the questions that we're going to be asking for. NeuroBlade has built the SPU, or the SQL Processor SQL Processing Unit. It does things a little bit differently, but does things in every way that matters the exact same. No end user ever has to rewrite a query. In fact, they don't even need to know that you've deployed an SPU in the system. The only thing that they see is their results come back faster. On the other hand, if you have a volume of questions, you can choose to use that performance and manage cost instead. Deploy fewer servers. At the end of the day, your users will not know the difference. They didn't have to do anything different. On the infrastructure side, we're architected a little bit differently, but we're a plug-and-play card. So it's easy to plug in. What you get when you plug this in is not only better and faster performance, but it's more energy efficient. And you get better predictability. When you analyze a query and try to figure out what's the performance I can get, is there a benchmark I can use to reflect? Unfortunately, every single one of you that I've talked to, every customer I've talked to over the course of my career says, I love benchmarks. They don't represent my data. So every POC, the vendor does a benchmark on a does a POC on a benchmark, then we need to do it all over again on my data to see the performance I'll get. There's no portability of these numbers. Even portability across benchmarks doesn't exist. Fundamentally, that is because the cost of a query, the time it takes to process a query, is a combination of the amount of data that we read and the complexity of the query that we run. What the SPU does differently is it eliminates the complexity as a factor of performance. So if I scan data X on query X and I scan the same amount of data on a completely different query, I get the exact same performance. The only bottleneck in the system is the I/O coming from the drives. So we are what we call a constant throughput machine. Now that means we're bound by the amount of data that you can get into the SPU. Depends on your infrastructure and your networking. If you're running PCIe Gen 4 drives, that's roughly 32 gigabytes per second. If you're running a network, you're going to be rate limited to your network and nothing else. From a server perspective, you just plug it in. We'll talk a little bit about what it means of coexisting in the ecosystem. But the idea is we're not going to redo things that the CPU does well. We're not going to reinvent the architecture. We're not going to make it move data to someplace unnatural. None of that has to happen. It's plug and play. And lastly, SQL's complicated. It's really hard, and it's ever-changing. And it has lots and lots of nooks and crannies that you really never want to go into. What we've designed the SPU to be is programmable and extensible. That means when you plug in, 80 to 90% of your queries just get faster. The set that we can't handle for whatever reason gets processed in the CPU as it does today. But because we took care of a lot of the processing before you even got to the CPU, your performance is already leaps and bounds what you had before. We don't need to replace the CPU. It's there to stay. We're here to augment. And it's available in a manner that you'd like. You can get it from us directly. You can buy it through Dell as part of a server that you're buying. You don't have to pick one. You can go up to 4 in a server, so now you're at 120x what you could do with the CPU. Did I say it coexists with your ecosystem yet? What do we mean when we say it coexists in your ecosystem? So far, I didn't talk about what you're using in your lake, what engine. And frankly, it doesn't matter. We support all of them. Today, we have integrations with Spark, with Presto, with ClickHouse. There's nothing in our product that is specific to a query engine, and all the query engines that you use have a very similar plug-in infrastructure. So we just plug in. So that placeholder for customer engine can be in your engine if you're using something other than the ones here. We come in with the standard plugin. How many of you have heard about Hive, Hoodie? Maybe? Some of you? Think of us as a modified version of those plugins. That's all you need to do to support our hardware. You plug in the hardware. Your storage stays the same. If you're using HDFS or S3, don't move your data. We never want to talk about moving data. Similarly, your queries are processed on your server farm. Nothing there has changed other than there's this extra card in that farm, in that cluster. Your use cases, again, don't change. Your end users, your data engineers, your data scientists, your business analysts, they don't even need to know. The latest engine that we've been integrating with, and the one that I alluded to at the beginning, is Velox from Meta. What Meta has achieved is 3x performance by rewriting the execution engine in a query engine stack. And what they've built is designed to be portable. Today, it supports Spark, and it supports Presto, and it supports Kafka, and there's more that they're working on. What they realized was getting beyond 3x is really hard. And that's where we're working together to integrate our technology, the SPU, into Velox. So now you don't have to stop at 3x, you get to 30x. And that's a conservative number, as I'll show you. The reason we're generic is we have a query interface language called Daxel. It's a data acceleration language that's meant to be open source over time and meant to be generic enough and model the interface and the way query engines interact. And that's what lets us trivially set up a connector and modify an existing connector to make it just work seamlessly. When we're in Velox, we benefit from Velox's portability. When we're not in Velox, we're portable ourselves, and we're just a connector away. If we talk about benchmarks, and we look at TPCH, we did a test on the 10K scale factor, so that's 10 terabytes. We're roughly 56x faster than a CPU. On a like-for-like cluster, the only difference is one is augmented with NEUROBLADE. And we didn't change any of the queries. We just ran it. And like I said, because the only thing that matters in performance is how much data that you're scanning, it's actually a portable number with queries that are not in this benchmark. Now, regardless of the query that we ran, we got fairly consistent performance. We're not all the way there, as I'll show you in the details, but we're well on our way. And the difference in performance compared to a CPU on a query-by-query perspective is quite dramatic. And we're available today. We have a demo running in our booth. This is a snapshot of the dashboard. We're on a 20-node Presto cluster and compared it to something that's unnatural, a single-node Presto cluster. This time, but it's augmented by NEUROBLADE's hardware. First chart just looks at the time it took to run the queries that we're showing. 152 seconds on Presto, 4.7 or 5 seconds on the accelerated cluster, accelerated node. On the right-hand side, just for the selection of queries from the benchmark that we ran 765 in that first hour. The cluster could run 23. If we look at a sample of the queries that we ran, now we were limited. A 20-node Presto cluster cannot run the benchmark at 10 terabytes. It runs about half the queries. So that was the family of queries that we were working with. You can see the numbers that we ran. The blue bar represents the 20-node cluster. The bar you can barely see represents the accelerated single-node performance when it's accelerated by NEUROBLADE. Somewhere between 12x on the low end and 40x on the high end. Now, we're ambitious at NEUROBLADE, so we chose not the simplest queries in the benchmark, but some of the more complicated ones. If we chose simpler ones, you'd get higher numbers. And then some of you would question me, is this real, KRISHNA? So we decided, let's take ones that are more realistic, they scan more data, and the queries themselves are more complex. Now, the beauty of the architecture is what the query engine sees is a file system and an accelerated query interface. Because it also sees a file system, we can support every table format that's there and all of the popular file formats. So whether it's ClickHouse, which is different from the others, or a Parquet-based one like Delta Lake, Iceberg, Hive, or Hoodie, we support them all. On the file format front, ClickHouse, like I said, is a little bit different, but Parquet and ORC are the open source standards, and we support them as well. If you're using something else, it's not a long stone's throw to support that as well. From an architecture standpoint, like I said, we're just a plugin. If we deep dive into any plugin generically, and specifically the Hive connector, because that's the most popular one today, you can break it down into two sets of functionality that it supports. The first set is one that works with the coordinator to identify what's the data that we need to scan, fundamentally. It does a translation from table to schema to files. It figures out how much of the data to select, so you don't select and scan everything. So you're taking advantage of the query engine itself and the planner. The second part actually manages a cache, and it manages access to storage. So we've got two components here that we need to, in the same connector, that need to understand NeuroBlade. And the work we did with Velox allows you to do that. Now, Velox is a little bit special, so we had to do things a little bit differently. But like I said, we've done this a couple of times. Behind it, nothing changed on your storage. What you do and what you see in the system when you work this way is we're just a cache. We're a large cache, we're a small cache, but we're just a cache. But we're not a standard cache. This is not about throwing SSDs into the system, because you have the ability to compute. Think of us as a computational cache, or think of us simply as an accelerator. Again, depends on how much performance you want out of the system and how much throughput you're able to drive through the system. And I'm not here just to talk about slides and talk about theoreticals. We've implemented this in a number of customers. I'm going to talk about two of them. One of them is probably one of the largest healthcare systems in the world. It's based out of the US, but it's comparable in size to the UK system as well. They started on Oracle RAC servers. They have several different sets of Oracle RAC deployed to manage all of the healthcare information that they have and to support all of the analyst queries that they need to support on a wide range of use cases. They had a couple of different storage technologies. Some of the systems used Oracle, others used NVMe storage acceleration, like Accelero, as the storage backend, depending on the specific performance that they need. This is not the only system that they have in-house. They also have a couple of different data warehouse systems in place. What they realized when they worked with us was all of that can be simplified and consolidated. Their initial deployment is focused on deploying Presto, an accelerated Presto cluster backed by NeuroBlade hardware. They're seeing and forecasting a 70% reduction in cost just on the infrastructure piece. We're not counting the performance benefits that they'll also capture. And they're seeing performance of roughly 30x faster. So now they have an opportunity to open up brand new use cases within the healthcare system, expand the types of analytics that they want to do, take new approaches to addressing fraud and identifying fraud in the healthcare system. And the second use case study is what we call a top internet company. It's one that I guarantee every single one of you use and probably have an app on your phone. Not probably, definitely have an app on your phone. It's one of the fastest growing on the planet today. They've already deployed Presto, they've already deployed ClickHouse, and what they're seeing is we have tens of thousands of servers deployed, millions and millions of dollars spent on infrastructure, and there's no end in sight. And they want to be more efficient. They want to be faster. And they want to enable their businesses more than they've ever done before. They're working with us. Again, they've seen 30x improvement in performance in the studies that they did. They came back and told us we could never see getting even half of what you can do today at any point in the future with our current approach. This means they can also, while capturing that performance, dramatically reduce the footprint that they have. Now they're opening up brand new use cases, improving things in a way that they've never done before. So think A/B testing. Think analytics around exposing analytics to customers that they've never exposed before, even productizing it in some cases. And to get this, all they had to do is redeploy their Presto engine, but with a plugin and with our hardware. And that's how they're getting there. With that, I'll open up for questions. Raise your hand and someone will bring a mic to you.